All right, so we've been mainly working with like up and down forces, and now we're going to add in some side forces, some side to side. So first, let's look at the person as the feeler. He is working with the floor, and that would be a normal force. Let's draw in our earth. And he's interacting with the earth, so that would be our gravitational force. And he is also interacting with the floor with a friction force. Okay, he is pushing the refrigerator, and that would be a normal force because he's pushing. So now let's list down the things that we do know. The force of gravity on the man from the earth is 800 newtons. Okay, that's our 800 newtons. And he's pushing the refrigerator at 600 newtons. And we also know that the refrigerator, so the force of gravity on the refrigerator from the earth is 500 newtons. So this force right here is 600 newtons. Okay, so let's draw the man's interaction first. So he is being pulled by the earth. So the force of gravity on the person by the earth is 800 newtons. And so then the floor in return is keeping him up. So 1, 2, 3. So the force of gravity, nope, sorry, not the force of gravity. The force, which is normal on the person by the floor, is also happening at 800 newtons. Okay, now he is pushing the refrigerator in that direction, so that means the refrigerator is pushing the man in the opposite direction. So the refrigerator is pushing the man in this direction. I don't know why that line's not straight. Okay, so the force, a normal force on the person by the refrigerator, is happening at 600 newtons. Okay, now we know that this is balanced because he's not moving, does not move, so that means it's balanced. So that means that we have a friction force going this way. So a force of friction on the person by the floor is happening at 600 newtons. Okay, so we know that our up and down cancel out and our side to side cancel out. All right, so now let's do the refrigerator. Okay, so our refrigerator is getting pulled down by the earth at 500 newtons. Okay, so the force of gravity on the refrigerator by the earth is happening at 500 newtons. And then the refrigerator is staying up by the ground at the same value because it's not moving. So it's a normal force on the refrigerator by the floor, and it's happening at 500 newtons. Now our side to side forces, so the man is pushing the refrigerator in that direction, so we are going to also do that here. So the refrigerator, it's being pushed, so normal force on the refrigerator by the person is happening at 600 newtons. Okay, and then conversely, the force of friction on the refrigerator by the floor is also happening at 600 newtons. So now let's label our Newton's third law pair. So we have a normal force by the person on the refrigerator, normal force on the refrigerator by the person. So this right here is going to be our Newton's third law pair. Okay, you want to look for the same feeler dealers, and same type of force, same exact value.